After studying this module, you will be able to know what are antidotes, learn which antidote is recommended for which type of poisoning, and to identify the types of antidotes. Now, the introduction to antidotes. In the majority of cases of acute poisoning, all that is required is intensive supportive therapy with attention. Specific antidotes are rarely necessary, beside the fact that only a few genuine antidotes exist in actual practice, though there is no denying the dramatic results that can be achieved with some of them in appropriate circumstances. Proper antidotal therapy can be life-saving in some situations. Antidotes are the doses of any substances which counteracts or neutralize the effects of poisons without causing appreciable harm to the body. Antidotes are specific to the poisons administered. If the administration of the antidote is quick enough and in sufficient quantities, it can help save the life of a human or an animal that has been poisoned. Antidote work in any one of a number of ways. Common modes of action of antidotes are as following. The first one is inert complex formation. Some antidotes interact with the poison to form an inert complex which is then excreted from the body. Example, chelating agents for heavy metals, Prussian blue for thallium, specific antibody fragments for digitoxin, dicobalt etatate for cyanide, etc. The second is accelerated detoxification. Some antidotes accelerate the detoxification of a poison. Example, thiosulfate accelerates the conversion of cyanide to non-toxic thiocyanide. Acetylcysteine acts as a glutathione substitute which combines with the hepatotoxic paracetamol metabolites and detoxifies them. Third, reduced toxic conversion. The best example of this mode of action is provided by ethanol, which inhibits the metabolism of methanol to toxic metabolites by competing for the same enzyme, means the alcohol dehydrogenase. Now the fourth, receptor site competition. Some antidotes display the poison for specific receptor sites, thereby antagonizing the effects completely. The best example is provided by naloxone, which antagonizes the effects of opiates at stereospecific opioid receptor site. Now the fifth, receptor site blockade. This mode of action is best exemplified by atropine, which blocks the effect of anticholinesterase agents such as organophosphates at muscarine receptor sites. Now the sixth point, toxic effect bypass. An example of this type of antidotal action is provided by the use of 100% oxygen in cyanide poisoning. Many of the poisons and venoms spread swiftly through the body by a bloodstream, so an early medical attention is indispensable for the effectiveness of an antidote. For example, an active charcoal is used as an effective antidote for a wide range of poisoning cases. Now, the common modes of action of antidotes. Here are some of the common modes of action in which the antidote functions. The first, by the formation of inert complex. Example, chelating agents for heavy metals, dicobalt adentate for cyanide. Second, accelerated detoxification. Example, thiosulfate is used as an antidote for cyanide. Third, reduced toxic conversion. Example, use of ethanol for methanol poisoning. Next, blockage of receptor site. Example, naloxone for opiates, atropine for organophosphates at muscarine receptor sites. Next, bypass toxic effect. Example, 100% oxygen in cyanide poisoning. Now, the need of antidotes. The person is required to be expelled out of the body as soon as possible. Therefore, there is a need to administer antidote because emesis or gastric lavage or other procedures may not completely help remove the poisons from the body. Or if the poison is administered other than the route of ingestion, it needs to be removed immediately. In other conditions, the poison may already be absorbed. So, it becomes more important to make use of the antidotes to discharge the poison out of the body. Next, classification of antidotes. Antidotes are classified on the basis of their mode of action and are grouped into the following categories. The first is mechanical or physical antidote. Second, chemical antidote. Third, physical or pharmacological antidote. And the fourth, universal antidote. Now, the mechanism or physical antidotes. The mechanical antidotes counteracts the effect of poison mechanically, preventing their absorption without inactivating the damaging action of poisons. These are the substances that neutralizes the poisons and they also help stop the absorption of poison in the body. These antidotes retard the absorption of poison by mechanical action. They are further subgrouped as following based on their functions. The first is activated charcoal, second demulcents, third bulky food. Now the activated charcoal. Activated charcoal is a fine black odorless powder. It is manufactured by destructive distillation of various organic materials, mainly wood, pulp, and then treated at high temperatures with a variety of activating agents such as steam, carbon dioxide, etc. Activating agents help increase the absorptive capacity. It has the property of small particle size and the surface area is very large. Slurry is prepared by mixing it with water and can be used for treatment. Activated charcoal acts by delaying the absorption of poison from the stomach. Activated charcoal is particularly beneficial in absorbing the alkaloidal poisons such as strychnine and to a lesser degree mineral poisons. In multiple doses, it significantly increases the total body clearance of opium, cyanide and phenobarbital. Phenol, salicylates, kerosene and paracetamol are moderately absorbed. The limitation of activated charcoal is that it is not very useful in dealing with the cases of corrosives, heavy metals, hydrocarbons and alcohol poisoning. Activated charcoal strongly absorbs aromatic substances such as acetaminophen, salicylates, barbiturates and tricyclic antidepressants, thus reducing their absorption from the gastrointestinal tract. Most inorganic substances are poorly absorbed by activated charcoal. Now the doses. It is given in a dose of 30 to 60 grams in children and 60 to 100 grams in adult in 5 times the quantity of water. The correct dose of activated charcoal is about 5 to 10 times the amount of drug ingested. Now, the demulcents. Demulcents are capable of forming a protective coating on the gastric mucous membrane, thus preventing the damage caused by the poisons. Demulcents include fatty products like egg, milk, albumin, oil, etc. But fat and oils should not be used for oil-soluble poisons such as kerosene, phosphorus, organophosphorus compounds, DDT, phenol, turpentine, aniline, acetone, etc. They act in the same manner both in corrosive and irritant poisoning. Dilutants such as water, milk and other similar drinks dilute the poisons and delay their absorption. Bulky food. Bulky foods like bananas, boiled rich or potatoes allow smaller amount of poisons to be available to the stomach mucosa for absorption as they are admixed with the poison itself. The bulky foods are commonly used in ingestion of glass powder as these particles are embedded in them and prevent damage to the stomach mucosa. Now, the chemical antidotes. The chemical antidotes disintegrates and inactivate poisons by undergoing chemical reactions along with the poisons. The chemical antidotes inhibits the action of poisons by forming harmless or insoluble compounds or by oxidizing poison when brought into contact with them. For example, potassium permanganate has oxidizing properties. It is used as a solution in a ratio of 1:5000 for opium and its derivatives strychnine, phosphorus, hydrocyanic acid, cyanides, barbituric acid and its derivatives atropine and other alkalis. It loses its pink color in stomach when it reacts with the poison. Some other examples are as follows. First is the tannin, means the strong tea, produces insoluble compounds with most alkaloids, glucosides and metals. Next is the common salt decomposes silver nitrate by direct chemical action forming the insoluble silver chloride. Next, a solution of tincture iodine or Lugol's iodine 15 drop to half a glass of warm water precipitates most alkaloids lead, mercury, silver, quinine and strychnine. Next is alkalis neutralizes acids by direct chemical action. Next, the acid neutralizes alkalis by direct chemical action. Only those substances that are harmless by themselves should be given. Example, vinegar, lemon juice, canned fruit juice. Neutralization of acids with alkali and vice versa should be avoided because exothermic reaction of neutralization can cause additional injury. Now, the physiological and pharmacological antidotes. These agents act on the principle of antagonism. Most of the known antidotes are only partial antagonists in their action. They act on tissues of the body and produce symptoms exactly opposite to those caused by the poison. They are not dangerous, but their use is limited. The two real physiological antidotes are atropine and physostigmine. They act on nerve endings and produce opposite effect on heart rate. Other examples are cyanide and amyl nitrate, barbiturates and picrotoxin or amphetamine. The physical antidotes act on the tissues and various systems of the body and produces signs and symptoms, opposite to the signs and symptoms produced by the poisons. They are basically of use when some of the poisons had already been absorbed into the circulation. They antagonize the effects produced by the poisonous substance. These are like atropine for organophosphorus compounds, physostigmine and neostigmine for dhatura and barbiturate for strychnine. Now the universal antidote. If the nature of administered poison is not known and it is suspected that two or more poisons have been taken, in those cases the universal antidotes are administered. They are simply the mixture of easily available substances. Usually it is a combination of physical and chemical antidotes. They are not very effective even if they are given soon after the administration of the poison. I repeat, the use of universal antidote is obsolete nowadays, but this can be definitely be used as a first aid measure at homes. Universal antidote comprises of activated powder charcoal 2 parts by weight, magnesium oxide 2 parts by weight, tannic acid 1 part by weight. 15 gram of this powdered mixture should be added to a half a glass of warm water before consuming and may be repeated once or twice. Now, the chelating agents as antidotes. Certain chelating agents are extensively used as an antidote for the heavy metal poisoning. They function by forming a firm non-ionized cyclic complex with cations. These complexes are stable, soluble, non-toxic and complexes with calcium and certain other heavy metals. Chelating agents inactivate a metallic ion with the formation of an inner ring structure in the molecule. When the metallic ion becomes the member of the ring, the chelating agents will form no toxic, stable, soluble compound with calcium and other heavy metals like arsenic, lead, mercury, copper, zinc, nickel, cobalt, manganese, etc. Due to this, they have high renal excretion capacity. The strongest of all the available chelating agents are EDTA, BAL and penicillamine. EDTA, ethylene diamine tetraacetic acid. It is a chelating agent and used in mercury, cobalt, cadmium, iron and nickel poisoning. The usual dose is 1 gram of EDTA twice a day for a period of 5 days. It is usually administered by slow intravenous infusion in isotonic glucose saline. The complex of chelates is formed when lead, which are water soluble, non-toxic, non-ionized, non-metabolized and excreted intact in the urine. The case of arsenic and mercury poisoning, EDTA proves to be a better solution than the BAL. EDTA forms readily soluble, practically non-ionized and non-toxic compounds with heavy metals. It is a useful antidote for those heavy metals that have an affinity for calcium. Now, BAL, British anti-levisite. It is also known as dimercaprol. BAL was originally used as an antidote for levisite, a vesicant containing arsenic that was used as war gas. This compound is used in heavy metal poisoning, especially arsenic, mercury, lead, antimony, gold and thallium, and also to some extent against copper. bismuth, etc. Heavy metals directly get attached to the sulfhydryl SH group and use the respiratory enzymes of tissue cells. Dimercaprol has two unsaturated sulfhydryl groups SH which combine with the metal and thus prevent union of arsenic with the SH group of the respiratory enzyme system. The compound, which is formed of metal and antidote, is highly stable in nature, which is then carried in the body fluids, mainly plasma, and then excreted in the urine. It is advised to give a 10% solution of Ba in arachis oil with benzyl benzonate. In case of severe poisoning, a dose of 3 mg per kg is recommended at an interval of 4 hours for the first 2 days, at 6-hour intervals during the third day, and at 12-hour intervals thereafter for about 10 days. And it is not recommended in case of liver damage. It has a limitation to be used for G6PD deficient individuals because it induces hemolysis. Now, penicillamine. Penicillamine is the product of hydrolysis of penicillin. It acts as a chelating agent because of possessing stable SH groups. It is advantageous to use this compound against poisoning due to lead, copper, mercury, and zinc preparations, as it can be used orally and continuously for a long time without producing any major toxicity. It is also known as cupramine and dimethylcysteine. It has a stable SH group. It is used in lead, copper, and mercury poisoning cases. It is especially useful in hepatolenticular degeneration, Wilson's disease, which is caused by a disorder of copper metabolism. A dose of 30 mg per kg body weight is given to a maximum dose of up to 2 grams per day in 4 equally divided doses administered orally for about 7 days. The main advantage of this chelating agent is that it can be given orally continually and it is much less toxic than EDTA. Now the next is DMPS, 2,3-dimercaprol propane 1 sulfonate. It is used in case of mercury, lead, and arsenic poisoning. The recommended dose of DMPS is 5 mg per kg of body weight. The total quantity of drug to be given is divided into 6 equal doses and is injected intravenously. Now, next is dysferrooxamine. Dysferrooxamine is a water-soluble compound that has a great affinity for ferric iron. This acts as chelating agent against iron intoxication, especially in case of acute poisoning, through its role in accelerating removal of iron from the body in case of hemochromatosis. Cannot be challenged. It removes iron from ferritin, hemosiderin, a little from transferring but not from hemoglobin and cytochromes. It can be given orally, intramuscularly as well as intravenously. It chelates iron and it is very beneficial in acute iron poisoning. A dose of 2 grams of dysferrooxamine in 5% of levolose solution is given intravenously to bind absorbed iron. Now, the summary. First, antidotes are the dose of any substance which counteracts or neutralizes the effects of poisons without causing appreciable harm to the body. Antidotes have their own significance in clinical toxicology. There are many poison information centers which help in recommending the antidotes for the specific type of poisons. Next, antidotes are also classified on the basis of their mode of action into mechanical and physical antidotes, chemical antidotes, physiological and pharmacological antidotes, and universal antidotes. Next, there are some chelating agents which forms a non-ionized cyclic complex with cations. Next, the complex of chelates is formed with lead, which is water soluble, non-toxic, non-ionized, non-metabolized, and excreted intact in the urine. The strongest of all the available chelating agents are EDTA, BAL, and penicillamine.